As discussed in the previous class, given two subgroups of a group G, call them as H and K. H union K will be a subgroup of G if and only if H is a subset of K or K is a subset of H, and that is exactly what we are going to prove now. So first of all, I will assume that H is a subset of K or K is a subset of H. Means if any one happens, then definitely H union K is going to be a subgroup. So we will say, assume that this is part 1. Assume that H is a subset of K or K is a subset of H. So without loss of generality, we will assume one happens out of these two. Either we can assume this or this, our choice. So I will say, without loss of generality, say H is a subset of K. So if H is a subset of K, therefore what will be H union K? That is the big question. And if you see this diagram properly, H is inside K, right? Meaning H is a subset of K. So what is our H union K? H union K will come out to be K again, right? So this is equal to K, but K is already a subgroup of G. So I will say which is a subgroup of G, and that is exactly what we wanted to prove. So we have assumed H is a subset of K or K is a subset of H, and we have shown that this H union K is a subgroup of G. Now we will go other way round, that is our part 2. So I will say, suppose this H union K is a subgroup of G. Now by using this fact, we have to show H is a subset of K or K is a subset of H, and this we are going to prove with the help of contradiction. Now what is a proof of contradiction or proof by contradiction? So whatever we have to prove, we will assume that that is wrong, and somewhere later on actually we will get contradiction. So let us assume that this doesn't happen. This doesn't happen means what? What is a contradictory statement to this? So I'll say, on contrary, assume that H is not a subset of K. Remember, a contradictory statement to OR is AND, right? So on contrary, assume that H is not a subset of K and K is not a subset of H, like this. Now the question is, H is not a subset of K. What is the meaning of it? The first question is, what is the meaning of H is a subset of K? And then we will try to understand the meaning of H is not a subset of K, right? So H is a subset of K means every element of H is in K. What I said? Every element of H is in K. So H is not a subset of K. What is the meaning of this? There is at least one element in H that is not in K, right? So what I will say here, this implies there exists one element, let us call it as X in H, such that this X does not lie in K. Similarly for K, and there exists Y belongs to K such that Y does not belongs to H. Now X is a member of H, Y is a member of K, so definitely X is a member of H union K as well as Y is a member of H union K, right? Because H union K either contains elements of H or elements of K, right? So I'll say here this X and Y both belongs to H union K. But remember, what we have assumed is H union K is a subgroup of G. Now since H union K is a subgroup of G, one step test we have to use or two step test we have to use. We can use either one. Okay, so let us think of two step test, right? So since H union K is a subgroup of G, so what will happen is if you take any two elements of H union K, then let me write it here. So what is the two-step test saying? First of all, H is a subgroup of G if and only if, definitely there are assumptions, AB belongs to H implies A multiplied by B belongs to H, and the another one is A belongs to H implies A inverse belongs to H, right? So here H union K is already given to us as a subgroup, right? So A union B will satisfy these two conditions, meaning if I take two elements A and B from H union K, then A multiplied by B will lie in H union K, right? So I will say here this implies X dot Y belongs to H union K. What we have used here? Two-step test. Okay. Now since X multiplied by Y belongs to H union K, so where will now X multiplied by Y, or we can simply call it as XY. So XY will lie in H or XY will lie in K. Remember, H union K either contains elements of H or elements of K. So therefore we are having OR here. Now in both the cases, if XY is in H or XY is in K, in both the cases we have to show that we arrive at a contradiction. Let us say out of these two, this happens first, means if XY is an element of H. Now let us see what contradiction do we get here. Or first of all I will say X is already in H, that we know. So I will say as X is already in H, and remember X is in H and H is already a subgroup of G. Since H is already a subgroup, it will satisfy this subgroup test. So here I have written two-step subgroup test. So since X is in H, H is a subgroup, so X inverse will also lie in H, right? So I'll say this imply X inverse lies in H. What is the reason? Since H is a subgroup of G. Now notice, in this case in the sense, if XY belongs to H, what do we have? XY is in H as well as X inverse is in H. So I will say here X inverse comma XY both are in H. But what is the first condition saying? If we are having two elements A and B from H, then the multiplication also lies in H. So this implies X inverse dot XY will also lie in H. But what is X inverse X? That is E, right? So this will actually imply Y belongs to H, because EY is actually Y only. But is it true? Remember what we have said here, Y is such a member of K that is not a member of H, but here we got Y as a member of H, which is a contradiction. Now similarly, if XY belongs to K, we need to show that we again arrive at a contradiction. So just I will explain that, you can write it. So this is simpler. If xy belongs to k, right, then what will happen by using similar logic, right? So if xy belongs to k, then you will say as y is a member of k, then y inverse will also be a member of k, right? So now in this case we have xy and y inverse to be members of k. But remember, k is also a subgroup, so the multiplication will also lie in k, but the multiplication of these two is nothing but what? X, and which contradicts to the fact that this x does not belongs to k. Thus in both the cases we arrive at a contradiction. So therefore we will say whatever we have assumed is wrong. Therefore what should be right? H should be a subset of k, or k should be a subset of H, and that is exactly what we wanted to